Hello, my name is CHEM, and this is my presentation for week 15 for the combined spectral problems. I found my molecule to be glutaric acid, also known under the IUPAC name of pentanoic acid. I was provided with the molecular formula of C5H8O4, and I'm going to show, to start with, the spectra. At the top I have the IR spectrum. At the bottom I have the carbon-13 spectrum. And on the next page I have the hydrogen spectrum. And I'm going to start explaining how I got to the conclusion that this is glutaric acid. My first step was to calculate the degrees of unsaturation of this molecule. And I provided the generic formula at the top. Carbon, the total number of carbons needs to be multiplied by 2. To that number we have to add another 2 and then subtract the total number of hydrogens and divide that by 2 in order to obtain the degrees of unsaturation. With 5 carbons and 8 hydrogens, following the formula and doing the math, I've discovered that I have 2 degrees of unsaturation. With this information, I can draw several conclusions just based on this. The molecule could possibly have 2 rings, unlikely due to the total number of carbons, 2 double bonds, 1 triple bond, or a double bond and a ring. And again, very unlikely that that would be the case. I don't really see any evidence for a ring or a triple bond. So then I move on to analyzing the IR spectrum. I'm seeing right away that I have a very prominent OH stretch at 3200 centimeters to the -1, followed by a CH stretch at 2900 centimeters to the -1, and another diagnostic feature for this molecule is the C double bond O stretch, which I'm noticing at 1700 centimeters to the -1. And then in the fingerprint portion of this spectrum, which is found under 1500 centimeters to the -1, I'm seeing some CH bending at around 1300 centimeters to the -1. Between seeing the OH stretches over here, 3200 centimeters to the -1, and the CO double bond, knowing that I have a degree of unsaturation of 2, I'm starting to think that these are most likely 2 carboxylic acids. And in order to reinforce my suspicion, I moved on to the carbon-13 spectrum. And I'm seeing that my total number of 5 carbons only generated 3 signals. One at 180 ppm, designated as signal A. The second one at about 33 ppm, that's signal B, and a short one at 20 ppm, designated as signal C. So I'm just going to explain each signal, and I provided the molecule on the side to the left just for simplicity. Signal A at 180 ppm is a typical finding for a carboxylic acid, meaning the C double bond O of the sp2 hybridized atoms. These are tall peaks. This is a tall peak, which is making me think that it's accounting for 2 carbons, which is supporting my suspicion of having 2 carboxylic acids present in this molecule. And then I'm explaining over here that the sp2 hybridized bond over here is polar, therefore generating that peak at 180. Signal B at 33 ppm is an expected finding for sp3 hybridized CH2 carbon, which is adjacent to a double bond between carbon and an oxygen. The carbon-carbon bond is nonpolar, and this peak again is a very tall peak. It's the highest one here, which is making me think that it's accounting for more than 1 carbon, in this case 2 carbons. And signal C at 20 ppm is an expected finding for an sp3 hybridized CH2, which is adjacent to other sp3 hybridized carbons. This is the most shielded carbon. It's the farthest away from the electron withdrawing oxygens of the carboxylic acids. It's a short peak, only accounting for one carbon. And again, the carbon-carbon bond is nonpolar. Moving on to the hydrogen spectrum. I drew the molecule in on the side just for simplicity. I'm seeing that this molecule only generated 2 peaks for its protons. Both peaks are downfield, which is making me understand that these are sp3 carbons that the protons are attached to. I have an integration on the tallest peak of 4H and an integration of 2H on the shortest peak. The 4H peak is the tallest peak and it's found at 2.5 ppm. This suggests that these hydrogens belong to 2 different carbons, but they are all in the same chemical environment, therefore generating just 1 peak, a tall one. And the splitting pattern for the 4H peak is a triplet. And if we analyze the molecule, we can see that the only adjacent carbon here is the 2H that I've designated as A. And following the n+1 rule, I can see that I'm expecting this to be a triplet. The 2H is the shorter peak. It's found at 2 ppm approximately. And the splitting pattern for this is a quintet. Looking at the molecule, we can see that the hydrogens designated as A are surrounded by 2 hydrogens on each side, which is going to generate a quintet following the n+1 rule. And this is also suggesting that it's in between other sp3 hybridized carbons. Of note, this information was provided. The OH peaks are not showing up in the NMR spectrum because they've been exchanged with the solvent. But if I were to see them, I would expect these to be a singlet and for the peak to be quite wide. The location can vary. At the bottom I have the molecular formula repeated, C5H8O4, degrees of unsaturation of 2. The IR spectrum identified functional groups are as shown over here for 2900 centimeters to the -1 of the CH stretch, 3200 centimeters to the -1 of the OH stretch, 1700 centimeters to the -1 C double bond O stretch, 1365 centimeters to the -1, the CH bending. The carbon 13 is demonstrating the peaks at 180 ppm, carboxylic acid, and then 40 ppm, the OH. The CH2 connected to the carboxylic acid, and then 20 ppm of the sp3 hybridized CH2 connected to other sp3 hybridized CH2s, and the chemical shift shown in the hydrogen spectrum was also discussed above. I just have the 2 peaks at 2.5 ppm and 2.0 ppm, and then the proposed structure is the glutaric acid at the bottom. Thank you very much. Have a good one.